Sasi. Please welcome him.
Good morning, everyone. Today's talk will be on CXML, VXML auditing for IVR pen testers. How many of you know what an IVR application is? Actually, everyone in this room has already used an IVR application. You know, remember when you make a call to your customer care, the first voice, computer-generated voice which responds back to you, which asks you to press a couple of options on your phone, or when if you've done a phone banking, the systems which responds back to you are the IVR applications. So our talk would be on CXML, VXML, call XML, and VXML. So these are the languages which are used to build those applications. And we'll be demonstrating some cool bugs and ways to exploit them. I'm Rahul Sasi, also known as FP on Auditors. I work as a security researcher for iFight Partners. iFight Partners is a risk identification mitigation services. We provide cybercrime mitigation technology and strategies. We got a headquarters in US with regional offices in India, China, Europe, and South America. I'm a member of Garage for Hackers. It's a community of like-minded people. We have members all across the world, ranging from security, consulting, research, and law enforcement. The forum could be reached at www.garageforhackers.com. So these would be the following things we'll be carrying out today. We'll have an introduction on IVR, what those applications are. We'll explain a small logic flow in a banking application, which is live. And we'll explain how to automate IVR brute forcing and how to fingerprint these applications. We'll explain how we could conduct an SQL injection via phone lines and buffer also attacks that could possibly affect these systems. Just explaining more about IVRs, a phone banking application. How many of you have used a phone banking application? It's just when you make a call to your bank, make a voice call actually to the bank, the system responds back asking you to enter your account number and password. So then it authenticates your system, and then you'll be able to do a lot of other transactions and all those things just by making a voice call. So these are the phone banking applications. These are called IVRs, Interactive Voice Response System, because they respond to, the input to these applications are one DTMF, the other is voice. That means you could say banking and the system will understand that you came in for banking. So it's got a speech recognition as well. And telephone assistant operators. Mainly every time you make a call to your customer care, you would be greeted with the messages. So these would be the IVR application as well. Then again, it is used in medical inquiry and all those things. So these are the different layers of an IVR application. We got the telephone network. Telephone network is nothing but everything that takes your call to reach the bank to the other end. So that is the telephone network. Then we have the TCP/IP network. So let's say we have an IVR application inside, and then it's a web application. So interconnecting, it's a basic general TCP/IP network which interconnects other computers together. And then we have the main one, the VXML telephony server. VXML stands for Voice XML. This is the server which hosts the IVR application. The CXML, VXML cores would be residing in these application servers, Voice XML telephony servers. And then we have the web application servers. So just to explain more about how the entire process of an IVR-based system works. So this funny guy is me. I make a call. So this is my phone banking. I'm going to make a call to my phone banking. The call first reaches the PBX of the bank or wherever I called. So I called 666. Now the PBX knows that the call has to be rerouted to the phone banking application. So the PBX converts it into a voice over IP call, sends it to the VXML IVR server, where the banking application resides. So if I make a call to 333, now the PBX knows that this call has to be routed to the support sender. So it is routed to the support application, support VXML application. So the job of a VXML IVR server, this one is the input which comes from the user. That is, one is the DTMF input, using the keypads. The second is voice. So this one got a DTMF detection. So it understands that the user pressed 1. It converts it to the numerical format of the pressed key, and it forwards it to the web application. If it was a voice input, like the user said support, it's got a speech detector recognition also. It converts the word which came to the alternate character format and forwards it to the web application. So right now, I want to do a phone banking transaction. I entered my account number and PIN using my DTMF phone. The VXML server will detect the DTMF tones, decodes it, and converts it into the numerical format and forwards it to the web application. So the web application is where actually the authentication takes place. So if the username and password combination is right, the server will respond back to the VXML server stating that this the username and password is right. So now the job of the VXML IVR server is to read out the error to the end user stating that you have been successfully authenticated or whatever. Now we could proceed with the rest of the transaction. So this is how the entire procedures work in an IVR transaction. And yeah, then we have the database actually. Every data which comes to the web application fetches, normal web app thing, it fetches the database, see if the credentials are right, get the response. So this is pretty much everything you need to know about how the IVRs work. As we already mentioned, this got two sort of inputs. That is, one is DTMF based inputs, and then it accepts text input. So these are the two inputs which are passed to the application, IVR application. So today we'll be covering, we'll be explaining a lot of VXML, CXML codes. VXML stands for Voice XML. Voice XML is used when your application has to have support for both DTMF and voice. CXML stands for Call XML. It is used when the application only needs a DTMF-based input. So that is about VXML and CXML. The structure is pretty much same to XML. It's got their own syntax and structures, everything. We'll explain in more detail about that later. So what actually made me interested in IVR security was my phone banking application. It allowed me to log into my banking account via a phone call. I just need to make a call to my bank, and IVR will greet me back. Then I have to enter my account number and password. And the password was my 4-digit ATM PIN. 4-digit ATM PIN how is it dangerous? How was using a 4-digit ATM PIN dangerous? There was clearly no CAPTCHA system for this IVR application to prevent a brute force attack. And the probability theory states that the probability of an event to occur, that here the event is multiple users having the same password. That is P of A is equal to the total number of events. That is the number of customers. That will be the number of user IDs would be very huge, divided by the PIN combination. So we have a 4-digit PIN combination that would be from 0001 to 9999. So 9,000 PIN combinations are there. So when you divide a very huge user list by the number of PIN combination, the number of chances, the possibility of multiple users having the same PIN would be same. So if I make a brute force program and tries to authenticate into the user account starting from account number 1000 to account number 2000 for the PIN 666, the chances of 100 users having the same PIN would be pretty huge. So let's say the lowest possibility be 10 accounts. So I just made a quick program and there was this very funny logic bug. If we made 3 invalid attempts to log into the system will block out the accounts. But every night at 12 o'clock, the accounts would be reactivated. So it was not a time gap, it was a specific time. So if the accounts are blocked at 12 o'clock at midnight, the account has to be reactivated. So this gives us a more opportunity. I mean, this makes it more wider, because if we start our brute force program at 10 o'clock at the night, and if we continue till 12 o'clock, and we try for this 3 different pins for multiple users, all the accounts will be blocked at 12 o'clock. But again, once the 12 o'clock is over, all the accounts will be reactivated. So then again, we got another 3 more attempts. So if you don't want to block the accounts again, from the time period 10 o'clock to 12 o'clock, we have like 5 different attempts. So what I did was I just made a quick program. All you need to make a brute force program for IVR is to know this AT and add commands. So these are the very few add commands which I used. I built a program in Python, which what it did was it simply tries to log into the system, tries with a particular user ID. I mean, I actually tested with my own user ID. Tries to log into the system and see if the password works, and keeps trying to the other accounts. So I'll show you the POC. It was tested on my personal account. We reported to the bank which was affected.
Welcome. Phone banking. For English, press 1. हिंदी में जानकारी के लिए. If you are an existing customer, press 1. To report loss of car,
So this will automatically do all
please
the
select
options.
from the following 5 choices at any time during this. Please enter your 16-digit debit card or 12.
So now we are entering the account number. So we don't have to touch our phone. The program will do everything for us. So my bank was asking for my 16-digit debit card PIN or 12-digit account number.
Please enter your 4-digit ATM or debit card PIN, or press 1 to Authentication is successful. The available balance in your account is 55,525
just start saving.
rupees and 58 credit. Press star to repeat. To know your last 5 transactions.
So this was the thing which made me interested in this applications, which made me into IVRs, and just so what I did was started coding in the CXML, VXML, started building applications for it. So generally there were a lot of other bugs which got revealed. So what all did we learn right now? The thing is, in expeditions, these applications are supposed to be secured. I mean, I don't see any company or any bank or whoever has an IVR applications goes for an audit just because they think this particular thing is secure. But in reality, it is not. And there is no proper firewall or captcha-like system to monitor the telephone traffic. So expectations are that it's secure, but in reality, it was not. And so today's talk will cover how to fingerprint these IVR-based applications from outside the world. Then we'll go on to input validation attacks. We'll explain the grammar files and VXML, CXML structure, how those applications usually take input and all those things. And then we'll have a example of a potential SQL injection via phone lines. And we'll have some examples of buffer overflows which could be done using a phone system. So I think everyone is comfortable with the VXML thing, IVR thing, right? In general, you got an idea about what IVRs are and what these things are, right? Right, cool. So everybody has knowledge on auditing a web application. So what we're trying to do is make it a sort of talk which, if you have to do an audit on these systems, you'll be able to do it. You know, for a web application, you just try with random payloads or custom payloads, send it to the web application. The web application will respond back with an error HTML code. You just have to read out the error and you could understand what was happening inside, and it's pretty much able to fingerprint web applications. But how is it possible to fingerprint IVR applications? The thing is simple. If you could trigger an error in an internal application, whatever way it is, if you could trigger an error, these systems are supposed to read out the things to you. The output of these systems are voice. So if you could trigger an error in the internal system, the application will read it out to you. So we will have a small demonstration of an IVR application, just how the input DTMF processing and speech processing thing takes place. So we'll have a demo. This is a demo application, and we'll explain. So this is
to the Nocon FB1H2S server. To test DTMF, press 1, or to test DTMF, please press any number key on your keypad. Looks like you pressed 5. Welcome to the Nocon FB1H2S server. To test DTMF, press 1, or to test speech recognition, press 2. Please say red.
Red.
No match.
Red.
No. Looks like you said red. Welcome to the Nocon FB1H2S server. To test DTMF, press 1, or to test speech recognition, press 2.
So this was a simple demonstration to show how the input processing takes place in an IVR application. So this is the structure of a CXML. This is a VXML code actually. It's pretty much same. We have the form here. This is an XML structure. We have the forms here. This is where we define all the inputs which have to be sent. So a prompt is like the input. If we want to prompt the user, like please enter your account number or please enter your password, it goes in the prompt field. The fields and in the prompt field. Then yeah, so this is and then we have the script tags. So script tags, it's like these things got inbuilt support for JavaScript. So whatever we have to dynamically do something, we could do with JavaScript. So in this particular thing, we have the forms here, the form and the block. This is like a division something, and the prompts ask you to enter your email address. So this is actually the user has to give the email ID or whatever email address. You just have to spell it out like FB1H2S and the function will process it, and this is how the thing works. So the important thing to know about this thing is, we have the files. All right. And this is another important field actually, the field type. The type defines if it's a digital input or a character input. So here it is a digit. The field type is digit, which means it's a numerical input, and minimum length is 1 and max length is 3. So here we could specify what is the minimum length if the user enters 3, he presses the key thrice, then stop accepting inputs and go on to another. So we have min length and max length. Max age is like if the user stop entering data for 3 minutes, 3 seconds, just go to the next stage. So these are the values. This is how they take input. Let's get back to our slides. So this is a buggy program actually. This is a buggy CXML program. Another one important thing to know is the grammar files. These are the files which define the set of words which a user might say. The commands to the systems are defined here. So if I say hack me, the system won't understand. Only the words which are defined in the grammar file are considered as an input to these systems. So here in our grammar file we have banking, support and test. The flow was, and then we have the fill field. That means if the user said something, go to this particular conditions, and if the user said banking, do this particular thing, and if the user said support, do this particular thing, else go to the test. So here the thing was this third thing, the third, third structure, the page was not defined. The page was not actually there. It was like, this is a buggy program I'm just trying to explain. The programmer might have left this thing unnoticed, so this is not there. So we'll just show you how and what happens.
Choose an option.
Banking.
Welcome to SB1 Bank. Have a great day. Choose an option.
Support.
Your call will be redirected to customer support. Choose an option.
Test.
That content is not available at this time. I couldn't find a web page. Error starting voice XML application. Failed fetch with code. 404. Not found. URL. http://127.0.199/. Test.php. That content has an internal error. Error starting voice XML application. XML parse error. S. Occurred in http://127.0.199/.
These are all the hosted applications which are on the server.
Dog cancel session counted equals unknown session accounted equals 1 session it equals E62B3788582192117 car 28 at 77 F06B.
It'll pretty much read out everything which is going on in inside the system. So all we have to do is trigger an error. So this is how we could fingerprint the applications. We just have to find a logic flow and the flow of the application, and the system is supposed to read it out to you, and it'll do it. So SQL injections via telephone lines. Is it really possible to do an SQL injection into one of these applications using a phone call? That'd be really cool, right? And the limitations why we can't do it is because a DTMF has got a limitation. Our phone has got a limitation of sending these much keys. We could only send a star, hash, or 0 to 9 characters to the applications. So, and we can't send a voice payload because only if the word is defined in the application, then only we could send payloads. So it's really hard to send an SQL injection payload to these applications only because of the limitations of these input characters. And the very basic SQL injection magic quotes, SQL magic quotes, that is the OR 1 is equal to 1, so which makes everything logically correct. So if you have a username password field, you just have to enter some junk values and followed with a semicolon and OR 1 is equal to 1, which makes the statement logically correct, and you'll be able to log into the system. So a very basic SQL injection, and the payload is OR 1 is equal to 1. This is called true injection, and there is this another concept called false injection. That means previously we entered a value. We entered a value here. We entered a value which is high. Then we terminate with a semicolon. Then we equated with OR 1 is equal to 1. That means ignore this part. If this is right, it's authenticated. So that is the typical SQL injection thing, SQL magic quotes. So here what we do is false injection. Instead of entering a password value, we just leave it with nothing. So if there's a password field, just enter nothing, then terminate with a semicolon, equate with a 0. That means we didn't enter nothing, nothing is equal to 0, and MySQL accepts this payload. This concept was dropped in ExploitDB by a paper with for the name of the person, but this was a paper which was dropped. And the same way will work for addition payloads. That means terminate with a single quote plus 0. That means something on this side if you're not going to enter nothing, it'll remain as 0. Plus it with 0, that is true. Then we have multiplication. So if you're not entering something here, that remains 0. Into 9 would be 0 again. And then we could try like if you multiply any number with 1, it remains 1. If you multiply any number with 0, it becomes 0. So the very interesting thing about these payloads are, they are all supported by MySQL. You could try these things. They are all supported in MySQL. The star, the multiplication star is there in the DTMF star. If you check your phone, you have a DTMF star key. So a payload like this could be sent to the server and would be accepted by the application. So I'll show you a demo program. Actually, the program actually asks the user to enter his user ID. So this time I enter the user ID elite, which is a wrong user ID because that particular value is not there in the database. Then again we enter the account number, the user ID elite. Then it welcomes me with my username because that particular value is there in the database. Now we'll try to do the actual SQL injection. So if we try the user ID *1 *1 *1 becomes this value itself, right? If you enter into the phone, if you enter, when you're asked to enter the user ID, you just have to enter these values. It becomes true because this value multiplied with 1 gives you the same value. So it greets me with Rahul Sasi. But if we enter the user ID followed by 1 into 0, this makes this value 0, which means the user is now not there in the application, in the database. It should give you an invalid user or no response. This way, it is possible to test an IVR application for SQL injection flows. We'll show a small demonstration on the concept which you just mentioned right now.
Please enter your PIN. You entered PIN 1337. Please wait while we process your information. No match is found.
So
please enter your PIN.
Now we try.
You entered PIN 31,337. Please wait while we process your information. Welcome, Rahul Sasi.
So that user is there in the database. Now we'll try it for
please enter your. You entered PIN 31,337 one times. Please wait while we process your information. Welcome, Rahul Sasi.
Now we'll try for the multiply with 0.
Please enter your PIN using. You entered PIN 31,337 times. 0. Please wait while we process your information. No match is found.
So actually this is how we could test for SQL injections using phone lines actually, DTMF payloads. We'll just explain how this application worked. Is it clear in the back? So this is how actually, like we mentioned, okay, consider this particular field, the send field. So actually, this is the IVR application. It takes in the input, the send field defines that whatever value is defined in the name value. If the name, if condition satisfies, send it to this particular URL. and the method is equal to post. I mean, the HTTP method is equal to post, and this is the server which is having the web application which does the authentication and all those things. So if the DTMF input comes, process it, sends it to this web application using a post method, and actually you could define the variables as well. Yeah, see, so this example, the name list is the forms, the different fields. Here we are passing the data which was collected from the user, converted into the numerical format or a character format, and is passed to the database. Now the actual database processing and all takes place in the web app end, and now it responds back. It'll send the response if it's authenticated and all what we did right now. So this is the code actually. We'll just move on with other attacks. The same thing is possible using, previously we just checked with DTMF based payloads. The same thing is possible with voice payloads as well. I mean, you could do the same in voice payloads. In IVR application, there is no way you could, I mean, it's a speech to text recognition engine which is powering the IVR. So if I want to say fp1h2s@gmail.com, clearly there is no perfect speech detection engine which could understand fp1h2s@gmail.com. So how, if you have to build an application which has got support for alphanumeric input, we have to split it down. That means I'll have to spell out the user. The program might have to make a program which takes my word one by one and puts it together. So I'll have to spell in my user like F, I'll have to say F, then I have to say B, I have to say H, then 2 S at gmail.com. Because com is a word which you could easily make them understand, or dot is also a word. So what happens is if I say at, the actual character value of at would be replaced with that. So if I say underscore, the character representation of underscore would be replaced. And if I say percentage, the percentage would be, the percentage value would be used. So the thing about this particular thing is we'll be able to send payloads, I mean very bad payloads if the percentage is defined. I mean if there is I'll show you the grammar files. This is how it works. In the grammar file it defines that, see, this is a program which supports alphanumeric input. So if the user said the email, if the word J is said, it has to replace the character representation of J. If the user says underline underscore, the underscore value would be replaced. If the user say dot, the dot value would be replaced. So it's defined in the grammar. The grammar file is the one which says these are the input which has to be accepted. So this is how alphanumeric input processing is worked, or how it's built in a VXML application. And the risky part is when percentage is used. I mean, if the user say percentage, it will be converted, percentage would be replaced with the actual percentage value. In one such situation, what happens is, we'll be able to make URL encoded payloads. That means semicolon, single quote, can be constructed with %27. So if I say %27, it would be the, so if this value is sent to the web application, it becomes a single quote. Same way, if I want to do the SQL injection thing, and the user says 1 is equal to 0, and over here 0 is equal to is the one which we need. So if I say 1 %3D 0, that becomes 1 is equal to 0. We'll have
Please spell your
this is the application which demonstrates the alphanumeric input processing thing, how alphanumeric input is accepted by the application, or how we have to input alphanumeric input?
F B 1 H.
Please spell your
F B 1 H 2 S at gmail.com.
You said fb1h2s@gmail.com.
So this is how alphanumeric input is processed, and like the way we mentioned, we will be able to construct these sort of malicious payloads. We will be able to do a union, you will be able to do a select using these sort of payloads when the application's got support for both both support for voice, and it's taking in an alphanumeric input. So if your application or your bank is using, this normally happens in a situation where the user ID, the bank's user ID is a alphanumeric one. It's not just a number, because many banks, for security purpose, they put it in alphanumeric input, alphanumeric user ID. So in one such situations, we could construct more critical payloads and extract more information out of the systems. So, and like we mentioned, is it possible to do a buffer overflow attack using these systems? Is it possible to attack if there is an overflow? Like clearly it is like the data from the VXML server is passed on to the web application. The web application might be a CGI application. If the CGI application's got an overflow and it's going to accept more and is it possible to really overflow one such stack using a phone call? The answer is yes. We'll show this example, this program which we mentioned previously. Over here, the value, the data, which is taken from the user, so here it is the DTMF data, which is taken in from the user, is sent to this particular CGI application. So if the data field in the CGI application is having an overflow, we'll be able to crash the internal buffer just making a phone call. And it is possible to reveal a lot of bugs using DTMF fuzzing actually. DTMF fuzzing is like sending the same way we fuzz other applications. We just have to send it with random data and see if there is a crash which occurs. So this is a vulnerable CGI application, the one which you mentioned. This is a CGI application which resides on the web server, which accepts the data from the IVR application. So whatever the user enters into the DTMF, it is passed on to this application. And it was having an overflow in the string compare function over here. Yeah, a string copy function over here. So it takes the value from the VXML, and there was an overflow over here. So we'll have a small demonstration of this. And what is HTTP server error 500? It's an HTTP server error 500. Internal server error, right? So if we pass this sort of data, we'll show with this an example actually.
Please enter your PIN. PIN 11111111111111111. Please wait while we process your information. Sorry, that content has an internal error. A web server error occurred. Error starting voice XML application, failed fetch with code. 500. Server error. URL, http://192.168.43.97/ CGI-bin/.
So this
v_test.cgi.
So this clearly says that the internal stack was crashed using the payload which we sent. The actual limitation of sending real payloads, since right now we are able to crash the stack, the problem with sending actual shell codes to the server is because payloads cannot have a slash key, because only if the application is a VXML application. That means if the input is a voice input, alphanumeric inputs like we mentioned before, then only we'll be able to send actual shell codes to the server. Else if the application is just DTMF based application, it's not possible to send a shell code because we have a limitation of zeros, ones and star hash key. It's not really possible to build a shell code out of it. How much more time do I have? 15. Okay. Okay. All right. So this is one. Then another thing which we are working right now is we'll just wind up with something which we are working right now. What other thing which we are working right now is all the applications and all the systems which is called DTMF detection has got an algorithm embedded in it. So consider it as if the PBX or as a telephone router or whatever it is, it's got a DTMF detection algorithm which processes the DTMF and converts it in numerical formats. So these algorithms are embedded in the VXML server, it's embedded in the PBX, it's embedded in the, embedded everywhere where DTMF is used as an input, just to process the DTMF. And the main algorithm which is used is called the Kruszeltels algorithm. It is actually a DSP algorithm. It's a pretty complicated one, but what we are working right now is if we could crash, the actual input to this Kruszeltels algorithm is the frequency, the DTMF detected using a frequency actually. So the frequency is the input, two different frequencies is the input to this DTMF detection algorithm. So if we could, so we are making a fuzzer which actually fuzzes the different DTMF detection algorithms with different frequencies. If we could do that, we'll be able to remotely crash many phone banking applications or many applications which depends on DTMF as input. So that is something which we're working on right now. I think I should wind up. I'll just take questions. That's it. Any questions? Sure.
I wonder, did you check real banks if they have these vulnerabilities or if they do some kind of sanity checking? I got, after my talk, I got an opportunity to test with one of the banks in India. And yes, we were able to find a couple of good ones over there. So even if I'm able to crash a remote phone banking application, that will be a very huge risk to the banks, right? If an attacker could crash a phone banking application sitting somewhere by just using a phone call, it is very critical. And we were able to find that sort of real world vulnerabilities actually.
More questions? No? Well, I want to thank you for coming, Rahul. Please, thank him. Next up here is the Corona jailbreak talk in about 10 minutes, so I'll see you then.